Hello and welcome to the channel. Today I want to talk about different multiplication methods. So I'm going to break down 4 different methods of multiplication and just kind of do a little compare and contrast. Which one's my favorite, why I think they're useful, and maybe why I think they're a little difficult. And then if you stick around till the end, I'm going to show you how they're all actually basically the exact same thing. So I'm assuming that we've all seen at least one of these methods before, but I'm hoping there's going to be one new one that you haven't seen. So let's get right into it. We're going to compare these by doing the same multiplication problem for all 4 methods. So I'm going to start with a relatively small, simple problem, just so we can all easily see the methods. We're going to multiply 23 times 14. So the first method I'm going to show you is probably the most common one, um, typically referred to as the standard method or the column method, but this is what I was taught in school. So the way it works is we line up our numbers in columns like this, and we're going to multiply single digits. So I'm thinking just looking at this 4 here, first multiplying it by the 3, that gets me 12. And then there's this very famous notion of we're carrying the 1 from the 12 up to the next column. And this carry notion will be a part of all of these methods. So next we do 4 times 2 to get 8, add 1, 9. And then now we do the same thing with the 1 here, except I just want to shift my answers over so they're directly underneath the 1. Sometimes to help visualize that shift, you can just write a 0 down under the first column. All right, so then we just do 1 times 3, 1 times 2, and we add these 2 numbers together. So just going down column by column, adding 2 and 0 is 2, 9 and 3 is 12, again carrying a 1, and 2 and 1 is 3. So there's method 1, column method. Method 2 is somewhat of a unique method, and this was first taught to me as the Chinese stick method. So we're going to represent our numbers 23 and 14 using sticks. Let's scroll up a little bit. So 23 is represented as 2 sticks for 20, and then separated 3 sticks for 3. And then same with the 14, going back the other way. Cross it there, that's our 10, and 1, 2, 3, 4 for 14. So with this method, all we have to do now is count the intersections of these sticks. And we kind of break it up into the right section, which is this right corner, the middle section, top and bottom corner, and then the left section, the left corner. So how many intersections do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I record the 12, and again, I write down the 2, and I'm going to carry that 1 over into this middle column and add that to whatever our answer is here. So counting the middle column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus the 1 gets us another 12, carrying the 1 to that far left column now. And there's only 2 intersections here, 1, 2, plus the 1 is 3. All right, same answer, so far so good. That's 3 methods down, sorry, 2 methods down. Next, I want to show you the grid method or the box method. So the way this works is, as you might imagine, we need to draw a grid or a box. Since we're doing a 2 by 2 number, 23 and 14, we have a 2 by 2 box. This box will get bigger if our number gets bigger. But this works by breaking up 23 and rewriting it as 20 and 3, and we'll write 14 as 10 and 4. So you'll notice we're separating the tens from the units very directly here. So in each of these boxes, I'm going to put the answer of each of these 4 multiplications. 10 times 20, 200. 10 times 3, 30. 4 times 20, 80. 4 times 3, 12. So now the idea is we just have to add all these together. I think the easiest way is to do left to right first. Gets you 230, 92, and then add those 2 together top to bottom. carrying a 1, and we get the same answer. All right, last method, and this was the one that I've learned the most recently, and it's kind of a variation on the grid method. It's going to start the same way. We're creating a grid, 2 by 2, and I'm going to record our numbers 23 and 14 similarly, but just a little different. We're just keeping the digits themselves and separating them in the boxes. I'm also going to record the 14 along this right-hand side, and you'll see why in a second. So I call this the lattice method. I don't know if it has an official name, but since we're drawing, this is the part. We draw these diagonals in, kind of looks like we're creating a lattice. So what we do now, individual multiplications again, just like we did up here, except now they're only single digits, so these numbers will be a lot smaller. And in the top triangle part here, I record the tens, bottom triangle, the units. So 3 times 1, I record as 0, 3. Units in the bottom, tens in the top. 4 times 3 is 12, so that's a 1 in the tens and a 2 in the units. 4 times 2, 0, 8. 2 times 1, 0, 2. So this method works now by we're looking along these diagonal columns we've created, and right to left, I'm just going to add up the digits. So there's only one number 2 in this bottom column, so I'll record 2. Right here we have 8, 9, 10, 11, 12. So again, I record the 2 and carry the 1 into the next column. Now we have a 1 plus 2 and 0 up here. And now we can just read our answer from left down and bottom to the right. 0322, that's 322. So there's our 4 methods. Let me talk a little bit about what I think about these methods, when you might want to use them, when you might not. And then at the end, let's talk about how they're all basically the exact same at the end of the day anyway. So first off, talking about this Chinese stick method, I think this is a very interesting method, and it's the most unique because the main part of it doesn't really use numbers at all. It uses this very visual graphic representation with these sticks. And you could do this physically with toothpicks too. For that reason, I think it's kind of neat and unique. It's a way to do math without pencil and paper, which we don't see very often. The downside with this comes when we have to do much larger numbers. I mean, just imagine trying to set up the sticks for something like 99 times 999, right? That's so many sticks that need to be laid so precisely along each other that I'm not even going to attempt it. That gets way too complicated, gets hard to decide where you're dividing, which parts you're counting. So as interesting as this method is, I think it falls apart completely when we try to scale it to larger numbers. So something similar for this box grid method. There is something I like about this that I'm going to talk about at the end, but in general, I don't like this just because, again, as we get larger numbers, this scales up not nicely and we have to do a lot of calculations. Let me show you what I mean by that. Let's imagine we were doing a bigger number like 5, 4, 3, 2 times 1, 2, 3, 4. 4-digit numbers. To do this in the grid method, we now need a much bigger box. Got to create a 4 by 4. And this is kind of a downside for me is creating these boxes. I think this is just a little bit cumbersome. I'm not a huge fan. And it kind of slows me down in the process. But also, look what happens here. And I'm trying to record this in the box method. Here has to be 5,000. Here's 432. And now 1,234. And even though each of these individual multiplications aren't that bad to do in my head, the numbers get big and then I have to add all of them together. So right away, 1,000 times 5,000, I have 5 million, which I have a hard time even fitting in here. 1,000 times 400. Let's see, 1, 2, 3, 4, 5. 400 to 3,000. 30,000. So right away you see these numbers get really big. It's hard to keep track of how many zeros I have here. And remember, in this method, we'd still have to go through and add them all together. And that gets a little harder to just, we're supposed to be able to just add these in our head left to right, but 5,400,000, 430,000, this just gets really big and really complicated really quick. So again, I don't like this method for the fact that it does not scale very nicely. That's so many computations we'd have to do to be able to do that. So let's look at our other two. We have now our standard old school method and this lattice method. So let's compare them with this big number that we are trying here. I'm going to do the column method first, our standard old school. So we line up in the columns just like that, and I do these unit calculations. So 4 times 2 is 8, 4 times 3 is 12, and we're carrying a 1. 16 and 1 is 17, carry the 1, and then 21. Now here with a 3, remember separate or shift over, put a 0 here. 3 times 2 gets us 6. 3 times 3 is 9. 3 times 4 is 12. We're carrying a 1 again. 3 times 5 is 15 and 1 is 16. Shifting again, now we have 2 zeros here. 2 times 2 gets us 4. 2 times 3 is 6, 8, and 10. Last one more 0 to shift, and it's the easiest one, just 1 times all that. So 2, 3, 4, 5. And yes, we have to add all this together, but look at all these zeros here. That makes these first couple of additions really easy. And then there's not that many numbers on the left side, so these additions are really easy. This is the beauty of this method, is that it makes each of your calculations very simple, and it tries to limit the number of calculations you have to do. So let's do this. 8 and all the zeros is just 8. 2 and 6 is 8. 7 and 9 is 16, and 4 is 20. Carry a 2. That's 3, 4, 5, 11, 12, 13. Carry a 1. 3 and 6 is 9, 8, 17, and 3 is 20. 1, 2, 3, and 4 is 7, and then 6. There we go, 6,703,088. Big number, for sure, but it only took us about twice as many lines to get there. We still used about 4 lines to do that 2-digit number before, and we just need a couple of extra to do this. The complication of this method is all of these carryings when we have to do multiple, carry a 1 here and then next time carry a 2. Sometimes we have to cross off what we're carrying and rewrite it. That can admittedly get just a little complicated to keep track of, and that's probably the one downside of this method. All right, and lastly, I want to see how this works in the lattice method. So again, a downside of this is this initial setup, because I need to do this 4x4 grid, which I don't like to do, but let's see how it works. Now we're just recording this as 5, 4, 3, 2. 1, 2, 3, 4. Let's throw our diagonals in. So a little bit bigger setup than the 2 digits. But look at all of these multiplications. There's 16 of them still, but they're going to go really quick. Just like this column method, this really utilizes single digit multiplication instead of large, lots of digit multiplications. So here we go. 0, 2, 0, 3, 0, 4, 0, 5, 0, 4, 0, 6, 0, 8, 10, 1, 0. 3 times 2, 0, 6. 3 times 3, 0, 9, 1, 2, 1, 5. And then down last column, 0, 8, 1, 2, 1, 6, 2, 0. So a few more numbers to write down here. But again, these are all single digits. All those calculations were real easy in my head. And now I just got to do this addition here. So we have 8. We have another 8. Then here we have 6, 7, and 9 is 16, and 4, 20. I'm carrying a 2 into this column. 1, 2, 3, 4, 5, and 6 is 11, 2, 12, 13, carrying a 1. 1, 2, 3, 8, 9, 17, 20, 0, carry a 2. 1, 2, 3, and 4 is 7. 5 and 1 is 6, and 0. And again, now we read our answer off just like that. 6, 7, 0, 3, 0, 8, 8. And sure enough, matches the same here. We can be confident we got the right answer. So interestingly, this wasn't all that bad, especially compared to our grid method here. Admittedly, we still had to draw this big grid, and the hardest part about this was all these little additions, because I kind of had to keep track of them in my head as I did it. They're very similar to these additions we had to do here. It's just a little bit easier for me to see them all written vertically out like this. But hey, ultimately this method wasn't too bad. I'd say fairly similar, probably my second choice for large numbers. It scales not too bad in the long run. So there's our 4 methods. Important thing to remember about this is that they all work, and it doesn't matter which one you choose. You can choose whichever one you like the best, which makes the most sense to you, and you can pick and choose and use different methods for different times. So I want to show you how all of these methods are ultimately actually the exact same thing. And that same thing is something that we've already learned in probably high school math class. And it's basically distribution, or what I learned as FOIL. So FOIL happens when the technical term for this is we're multiplying binomials. So something like 2 numbers added together times a different 2 numbers added together. So FOIL stands for, let me just refresh on what this solution actually is. We multiply the first terms, that is the A and the C. There's first terms. And then outer terms, O, that's A and D. And we're adding all these together. Inner terms, B and C. And last terms, B and D. Now another way I've seen this taught in high school is actually exactly the same as this grid method. We put A and B here, C and D here. We do these multiplications, AC, BC, AD, BD, and we add them all together. So notice how that is exactly this grid method we started with. And I think this is the reason why they started teaching this grid method in the first place, is that once you get used to doing this, this becomes very natural. And FOIL, this becomes a big deal in algebra and later on, the ability to do this. This is just the most generalized version of it. But if you learned multiplication in this way, this becomes very easy to now transfer this to FOIL, or however you think about this, distribution, factoring. And the key of this is recognizing we're just taking each of the 2 pieces in the first part, multiplying them by each of the 2 pieces in the next, and then adding it all together. So notice that these values here in the generic A, B, C, and D, that's exactly what comes out of our grid method here. AC in this case is 200 plus AD, which would be 30. And notice how these exact same values, 230 and 92 added together, also come out in our column method, 230 and 92. So there you go. I hope this was helpful, and we'll see you next time. All right, thanks for spending your time with me today. Remember, if you have your own math needs, you can hire me as your own one-on-one private tutor. I'll put links in the description on how to do that. And if you have any suggestions on where you'd like this channel to go, please feel free to leave a comment, and we'll see you all next time.